Hi folks, Mr. Long here. I'm going to do a screencast on the natural logarithm, which is the log of e to the x. And we remember that you've just done a screencast or a lesson on the Euler function or Euler function, where the derivative is the same as the function value. In other words, if you've got like 1,000 objects, that the objects are growing at 1,000 objects per, say, hour. So the rate of change is the same as the function value. So what we're going to do now is just move over and do some work in that area. Okay, so here we go, folks. We're going to do some more work here, and specifically, what we're going to do is do some work on the screen here. So let's go over something like this. So we've got here's a graph of 2 to the x, and also of log of x to the base 2. So we have to remember what are what does a logarithm represent? Well, it's the inverse. The log is the inverse of the exponential. So if I'm looking at the log, I have to remember that y equals log of x to the base 2, that's the evaluated power, and y is the exponent, okay? And this is the base, okay? So the x-axis for a log is the evaluated power, the y-axis is the exponent. And we remember that they are, because they're inverse functions, the exponential and the log, we remember that it's a reflection over the line y equals x, right? So we can see that this is a line of reflection, and we know that it makes sense that when you have an exponent of 0, your y value is 1. Like anything, the exponent of 0 is 1. Well, what is going to be true on the inverse then? So on the inverse, we have this notion right here that, remember that x is the evaluated power, and that is the exponent. So if you have an exponent of 0, the evaluated power is 1, so you get an x-intercept there. What about going as you go this way? Well, as we go down and further, that means the exponent is getting very negative, so a very highly negative exponent, and the evaluated power approaches 0, which makes sense, right? So if you've got a negative exponent, and it's 2, this is base 2, so 2 to a really negative exponent is going to be awfully close to evaluated power of 0. Like 2 to the negative 20 is going to be really, really, really close to 0. Okay, so that's that relationship. Well, what about if we start to look at e to the x then? Is there a logarithm for e to the x? Well, of course, there's a corresponding logarithm for every single exponential function. Now we write it as y equals ln x, ln of x, but another way we would write it is log of x to the base e. This is just our shortcut, okay? Now in some places in the world, they write it out in full, log of x to the base e, but certainly here in Canada, we always write ln x, and it just means, they call it the natural logarithm, the log of x to the base e. So some things to consider, same thing as before, you're still going to get an x-intercept of 1 because you're going to have 1 comma 0, because remember that for the log, this is the evaluated power, the y-axis is the exponent, right? That makes sense. And that makes sense here that this 1 is the evaluated power, that 0 is the exponent. So it makes sense if you have an exponent of 0, the evaluated power has to be 1. So again, this is log of x to the base e. So, what we have here is things like right here. So what does it mean to have a value of 4? Well, that would mean that e to the x equals 4. Okay, so what should that be? If I go across over to here, if I go across over there, that would make sense that this may not be log of x to the base e, because e, of course it is. Yeah, so what should it be? What exponent, I'm sorry folks, what exponent should I get? So remember the e is like 2.7 something, right? So 2.7 to the x equals 4. Well, how many times do you have to multiply 2.7 by itself to get to 4? Well, if you do it once, you get to 2.7. If you do it again, it's 2.7 times 2.7, which is 2.5 times 2.5 is 6.25. So really, to get to 4, you're going to have to multiply by itself a little more than 1 time. Well, there's 1 right there. So it looks like you have to multiply 2.7 by itself about 1.5 times, or 1.5 factors. And that'll get you to a value of 4. Okay, so But the best way to think of this is e to the 1, e to the 2, etc. Okay? So your answers over here, are the y value here are the exponents. Okay, the y value there is exponents. Anyway, I think you get the idea. So let's go through some of this. So here we go. Hopefully you already watched the review of log rules, okay, because I wanted you to do a review of logarithm rules. And there's your logarithm rules, but now written with ln. So some things, different things. What's the ln of 0? In other words, that's saying the evaluated power is 0. So y equals ln of 0. So what is y if the evaluated power is 0? In other words, e to what exponent gives us 0? Well, is there any number of times you could multiply 2.7 over and over again to get 0? Don't think so. D and E. So this is just kind of a review of logs too. All right, so what do we know about ln and log? What are they? They're inverse functions. So how do you, if you have x cubed equals 8, how do you solve that? Well, you do the inverse on both sides. You do the cube root on both sides, right? That's how you solve that. The inverse of x cubed is cube root. Well, what's the inverse of ln? It's e. Okay, so I would take the e on both sides. What is e to the ln x? It's just x. It's a composition of inverse. It undoes. It's an undoing function. And then e to the 0 is anything to the 0, 10 to the 0, 20 to the 0, 5 to the 0. It is 1. Okay, so that solution, if ln x equals 0, x equals 1, which makes sense. That's our x-intercept, folks. Right? We already know that from right here. That's the x-intercept right there. Okay, what is the ln of e to the x? Well, again, that's like taking the cube root of x cubed is just x, right? So again, this is an undoing function. So ln of e to the x is just x. Similarly, what if I do it in the reverse direction? I do the ln x as an exponent on e, I'm going to get x as well. Okay, those things definitely going to be true. All right, so let's combine what we've just learned about with respect to ln and simplifying and things. What we're going to do now is solve this logarithmic equation, and we're going to use our log rules. So if you remember, when I'm solving a logarithmic equation, whenever possible, I want coefficients represented as exponents. So remember this rule, the power of a log rule. So I know that when there's a number out front, it originally could have been the exponent here. So in other words, I can write this as ln of, now I'm going to do x to the, well actually I'll leave it as root x, and then I can put the exponent of 2 on that. So root x squared minus ln of 1 minus x equals 2. And so I have that. Now, what is root x squared? Root x squared is just x, right? So now I have the ln of x minus ln of 1 minus x equals 2. Okay, next. Which rule can I use? Well, I'm subtracting. Remember that a ln of x is just an exponent. This is an exponent. When you subtract exponents, what do you do with the evaluated powers? So that's the evaluated power, that's the evaluated power. That's what's inside the bracket, right? So when you subtract exponents, right, that's subtraction. When you subtract exponents, you divide the powers. So how do I show that? That becomes the ln of x over 1 minus x equals 2. But what's the base here? Even though I don't show it, right? Just like base 10 I don't show it, ln I don't show it, but the base is e. So what I want to do now is isolate for the evaluated power. And remember that b to the exponent, or we called it n, equals L the log, right? Sorry, equals b to the n equals the evaluated power. And so if I want to isolate for the evaluated power, I have to just write b to the n, right? So my base is e, my exponent, the base is e, the exponent is 2. So I know that x over 1 minus x, which is the evaluated power, that equals e squared. Okay, so then there's a bunch of algebra of going back to grade 9 and 10 algebra to solve this equation. So I need to multiply both sides here by 1 minus x over 1 minus x, right? And then I'm going to end up with x equals e squared times 1 minus x. Then what do? I have to, I'm isolating for x, so I've got to expand through by e squared. X will equal e squared minus e squared x. Remember, e is just a coefficient, right? E squared is 2.7 squared, approximately. And now I need to collect the x terms on the left, so I'm going to add e squared x on both sides. So I've got x plus e squared x equals e squared. Now I need to factor out x. X bracket 1 plus e squared equals e squared. And now I can just divide both sides by 1 plus e squared. Okay, by the way, I was just going around that and around that. So I just divide both sides by 1 plus e squared. I'm going to get x equals e squared over 1 plus e squared. Now, I can put that in my calculator and get an approximate value, but that's exact, okay, because e is an exact value. All right, folks, so that is an introduction to ln and the algebra that you can do with ln. In the next short video, I'm going to do the algebra that you can do with e, okay? But the two are interconnected.